Alright, in this video, I'm going to do a quick limiting reagent question that involves a solution. So we have 0.45 grams of magnesium being added to a 200 milliliter 0.9 molar solution of HCl. Determine the mass of hydrogen gas produced. So what we got to figure out is this amount of magnesium going to run out first? Or is this amount of HCl going to run out first? Let's do the balanced chemical reaction first. Magnesium as a metal can just be written like that. Plus hydrochloric acid, HCl, is going to go to H2 gas and MgCl2. Now we need a 2 here to balance that, and we're good. Now the magnesium, 0.45 grams. So I'm going to calculate the number of moles. So I got 0.45 grams divided by the molar mass of magnesium, which is 24.3. And that's going to give me 0.45 divided by 24.3, 0.0185 moles. Okay, now I'm going to calculate the moles of HCl. I have a 0.2 liter volume solution, so 200 milliliters. Divide out the milliliters, put in liters. So that is 0.2 liters, okay? And its concentration is 0.9 molar. So my moles, my formula is C equals N over V. So 0.9 molarity is equal to moles over 0.2 liters. And I have 0.18 moles. Now obviously this is much smaller than this, so this is going to be my limiting reagent, but I might also just want to make sure that I take, if they were closer, I'd have to take my mole ratio into account here. So I could divide this by 2 since I need 2 of them for every one of this, and see that in terms of my comparison I should be comparing 0.09 and 0.0185, but since 0.0185 is so small anyways, there's no real reason to do this. It's not necessary because this is very, very small. We know what's going to be limiting reagent. We know it's going to run out first. So with that in mind, that's how much hydrogen gas is produced, right? They're in a 1:1 ratio, so I don't need to do a mole ratio. So I want my mass here, so I need my molar mass. 2 times 1 gram per mole for hydrogen. Don't forget that it's the diatomic, so it needs to be 2. And so my moles is equal to my mass over my molar mass, which means 0.0185 moles is equal to my mass divided by 2 grams per mole. So I get a mass of 0.037 grams of hydrogen gas. So that is the mass of hydrogen gas produced, H2. So again, when I have the amount of both initial substances, I have to convert them both to moles or number of particles to see which particles are going to run out first. When I did that, this guy was much lower, so I recognized that he was going to run out first. But I still need to account for my mole ratio just to make sure. So I need 1 in the recipe of this and 2 of the recipe of that for that, so I'm going to run out of that twice as fast, so I divide it by 2. Still, that's much lower, so I use that to predict my amount of hydrogen gas and calculate the mass.